In this problem, we're being asked to find the area of a rectangle that's shown in this graph. If we're going to find the area of a rectangle, we of course need to know its width and its height. Let's start with the width. To determine the width, I'm going to need to know where the two vertical asymptotes are for this graph. But a vertical asymptote occurs in this graph whenever the denominator of the original function g of x is 0. So to find out where the vertical asymptotes are, I should set my denominator equal to 0 and solve for x. Isolating the trig function makes this an easy equation to solve because, of course, the sine of pi over 2 is 1. And if we were to go to the next value of x for which the sine of x equals 1, it would be 5 pi over 2, which is, if we think about it in a unit circle sense, coterminal with pi over 2. And therefore, those are the two vertical asymptotes. I want the distance between them, of course, which is the base of my rectangle. And so if I subtract 5 pi over 2 minus pi over 2, I get the width of my rectangle, which is 2 pi. Now let's concentrate on the height. One clever way I could find the height here is by finding the y-coordinate of the local minimum. In other words, the y-coordinate of point A. Now, in order to find that, it would be helpful if I knew the x-coordinate, because I could then plug that into the function and get the y-coordinate. Well, it's not too hard to determine the x-coordinate, because it is, by the symmetry of this function, the midpoint between the asymptotes. And so, if I find the midpoint of pi over 2 and 5 pi over 2, I get 3 pi over 2. That's the x-coordinate of point A. But of course I want the question mark, which is the y-coordinate of point A. Well, as usual, if you want the y-coordinate of a particular point on a function, you plug the x-coordinate into that function. Nothing new there. Working this out leads me to a y-coordinate of 3. So now that I know that the question mark is 3, I know that the height of my triangle is 3, and I now have the base and the height. Area equals base times height. I have a total area of this rectangle of 6 pi, and that completes this problem.